The first exercise in the cell membranes lab report that you're going to be filling out is looking at two different colored dyes and how they diffuse across a plate of agar. So in the lab itself, you'll see that it's listed as potassium permanganate and then methylene blue. And I did have a note for you to basically change this Janus green into methylene blue, and you're going to be recording that. So we'll just say methylene blue for these. Okay. The table has 4 different sections. Each of the colors, the potassium and the methylene blue, there's a temperature difference, so 5 degrees Celsius versus room temperature. And you'll see in the lab that the 5 degrees Celsius is basically on ice. So what you're going to be looking at is you're going to be measuring these dyes and how fast they move across the plate of agar. So the starting time at 0 minutes, so at the very beginning of the experiment, at room temperature, the methylene blue is at 7 millimeters, and they're doing that based off of this ruler. So basically the methylene blue, the diameter there is at 7 millimeters, and the potassium is at 8 millimeters. And then at the 5 degrees Celsius, the methylene blue is at 6 and the potassium is at 11. So when you go to fill in the chart, let's do it like this. Okay, so this is potassium at room temperature, time 0 minutes. So room temperature, potassium, 0 minutes. The diameter is 8 millimeters. The 5 degrees Celsius, 5 degrees Celsius here, potassium 11 millimeters is the total diameter. Okay. At the 5 degree mark for the methylene blue, we are at 6 millimeters. And then at the 5 degrees, let's see, methylene blue at room temperature, 7 millimeters right here. So total diameter, 7 millimeters. All right, so that's the first row for the chart. And then the next slide is going to measure the diameter of both of these at 0 minutes and then at every 15 minutes. So at 15 minutes, you can see that the potassium has gotten a whole lot wider. So the diameter here is 14 millimeters across from side to side, whereas the methylene blue is only at the 9 millimeters. So we're going to record that on the table. So we are looking at the room temperature one first. So potassium at room temperature after 15 minutes is at 14 millimeters, because that's what they've measured for you. And the methylene blue at room temperature is at 9 millimeters. Okay. Now, what we're trying to measure here is the distance of diffusion and the rate. So initially, for this first one at time 0 minutes, there is no diffusion, so there's 0, because this is basically the baseline. This is where we're starting, so the rate would also be 0. Same thing for the others at time 0. Nothing has happened yet, so there hasn't been any diffusion, so there's no distance to measure, and there is no rate. All right. Now, looking at the 15-minute mark, we're basically measuring the difference between the 0 time and the 15-minute time. So if you look down here, they've got a little formula for you. Distance diffused is the diameter of each reading minus the initial diameter. So the distance of diffusion at 15 minutes would be 14 minus 8, which would be 6 millimeters. All right. The rate equals the distance in millimeters divided by the elapsed time. So the rate would be the distance, which is 6, divided by the elapsed time, which is 15 minutes. So that gives you 0.4 millimeters per minute. All right, let's look at the methylene blue one. So if we had a total diameter of 7 initially, and then we went up to 9, then the difference there would be 2 millimeters. And pull up the calculator here. So our rate is the difference, which is 2, divided by the time, which is 15. So divided by 15 gives you 0.13 millimeters per minute. All right, moving on. Looking at the 5°C time, the methylene blue is at 8 millimeters and the potassium is at 12. So let's fill that in on our chart. So methylene blue, what did we just say? It was at 8? Yeah, 8 millimeters. Potassium was at 12. So the difference between 11 and 12 is 1, so it's only moved by 1 millimeter. So the rate is the distance it's moved, which is 1, divided by the elapsed time, which is 15. So 1 divided by 15 gives you 0.07 millimeters per minute. Looking at this one, it's gone from 6 millimeters to 8, so the distance is 2 millimeters. And so the rate would be 2 millimeters divided by 15. So looking at our calculator, 2 divided by 15, 0.13. And so that's how you do the chart. So the formulas are listed down here for the distance diffused and how to calculate the rate, and then the numbers that you're actually filling in you will find in the lab itself. So they actually do the measurement for you. So it progresses through 30 minutes and then through 45 minutes.